Now, we'll be looking at the second application, which is finding maximum and minimum values on an interval. So let's take a look at this graph with points A, B, C, D and identify the absolute and relative extreme values of this graph. The absolute maximum is the highest point of the graph. The absolute minimum is the lowest point of the graph. Now, this peak right here is not the highest point, but is the highest point in this local area. So it is called the local max, aka relative maximum. This point is a relative minimum. To identify the location of absolute extrema, you need to compare the y values, so a data table would be useful. To identify the relative extrema, you need to identify the locations where the slope is 0. Since we have a horizontal tangent line, f prime of b will be equal to 0 and f prime of c will also be equal to 0. Now, let's work on a practice problem. Let's say that f of x is equal to x squared minus 4x plus 9 and identify any absolute and relative extreme values of the function in the interval between 1 and 4. Firstly, identify the critical points. That's when the first derivative is equal to 0. When we take first derivative of f of x, we get 2x minus 4. When the first derivative is equal to 0, x equals 2. To determine whether this is a relative min or max, we plug in values from the left and right of 2 and see if the sign changes from left to right. When x equals 1, f prime of x is a negative value, so the slope goes down. When x equals to 3, f prime of x is a positive value, so the slope goes up. If it changes from negative to positive, it is a minimum. Thus, where x equals to 2, there is a relative minimum. Let's move on to the absolute extreme value. Once you have all of the critical points, make a table. In the table, put the endpoints of the interval and in between that, the critical points. Now, substitute the values into f of x and get the y values. Notice that 9 is the highest y value, therefore it is the absolute maximum of the function. 5 is the absolute minimum value because 5 is less than 6 and 9. In addition, it is also the relative minimum. So that's how you could find the absolute and relative extreme values. Now, let's move on to the final real-life application of derivatives.